Hello, this is Hoshita from Team 12635, Kuriosity Robotics in Palo Alto. This is the first video in our first ever YouTube software series, and today we're going to be talking about computer vision. So, what is computer vision and why is it important? Computer vision is simply using a computer to process and understand images and to do something with the information it gains. In FTC, the information can be used in various ways, but the most fundamental way of using CV is to help with randomized tasks. This year, for example, we have randomized parking spots at the end of auto for extra points. There are several ways to use computer vision in FTC. For localization, OpenCv and Vuforia can be used. But for today's video, we're going to focus on single sleeve detection and using OpenCv. Easy OpenCv is essentially a way to use OpenCv for FTC, and it has a lot of useful features. Some of these features include working on the expansion hub, control hub, phones, and webcams. It allows for concurrent streaming, and it will run on a separate thread, so it will avoid slowing down your program. But in order to use it, we need to set it up. So follow the instructions on the GitHub README and set it up. The link is in the description below. Images are basically stored as a matrix of values. OpenCv stores images as mats. Mat is basically a class with two data parts. The matrix header, which contains information such as the size of the matrix, the method used for storing, the address in which the matrix is stored, and so on. And it has a pointer to the matrix containing the pixel values, which takes any dimensionality depending on the method chosen for storing. The matrix header size is constant. However, the size of the matrix itself may vary from image to image and usually is larger by orders of magnitude. So let's start with filtering images. Images can be filtered by a range of colors. You can do so by utilizing the .inRange function to do so. You put the mat you want to process, the min threshold in a scalar, which is basically a lower color value, the max threshold in another, and the mat you want it to read to. It will set the mat you want it to read to a black and white image, where only pixels that were inside the range in the original image would be white. Color spaces can also be interchanged with the image proc.cvt color function. The submat of an image is a copy of a specific part of a mat, defined by rectangle that you give it. It's useful for processing specific parts of an image. Contours are the curves that join all continuous points of the same color value or intensity. It's very useful for shape analysis and object detection. So here's an example of using such contours. You can very rarely get a perfect filtered image, and there will almost always be noise. To reduce this noise as much as we can, we use OpenCv's Morphology. We're just going to talk about the four most useful ones, as the others have extremely niche use cases, and you probably aren't going to use them. First up is erosion. It basically cuts away at the image, and it's good for removing unwanted selections. If you want further technical detail on how it works, you can go to the OpenCv website for detail. Next is dilation. Essentially the opposite of erosion, it can be used to close holes in objects, and can be combined with erosion to remove unwanted selections and recreate the wanted eroded parts. And instead of doing that, you can just open the image, which is just erosion followed by dilation. Finally, there's closing, which is the opposite of opening, which dilates an image and closes it. It can help close holes in selections and trim the selection back down to size. Now that you've learned the basics of processing an image in OpenCv, you can start taking next steps and implement your own way for a signal sleeve system. While we've prepared you for the basics of filtering, you still will have many questions. But Google is your friend, and the FTC community has lots of great videos to further guide you along. Additionally, OpenCv Docs has great documentation for most functions. And the comment section below this video is always open for questions. Thank you for watching, and we hope to see you watching our next video as well.